Hello, guys. Welcome back to Zone African Motives. Still on engineering science and three, working on forces. We've got a special question that we are going to consider or that we are going to work on, where we are given on 3.1, what is the relationship between the resultant force and the equilibrium of a system of forces? All right. What is it that we have in relationship between these two, a resultant force and the equilibrium? All right. So what we know is that these two, they consist or they have the same magnitude, but they are of opposite direction. So we can simply say they have, all right, so they have the same magnitude. So the magnitude is going to be the same. So they've got the same magnitude, but they are going to be of opposite direction, but okay, let's just say, but in opposite, let's just say, but opposite in direction. All right, in direction. So this is what you're going to have as long as relating a resultant force and the equilibrium of the system of forces. All right, on question 3.2, we are given the following data refers to four forces acting at a point. So given coplanar forces that we have, they are acting at a point. So these are the forces that we have, and calculate the sum of the vertical components and state their direction. Also, the sum of horizontal components and also state their direction, the magnitude of the resultant force. That is 9 marks for everything. All right. So whenever you are given a question of this nature, what you need is to present. Remember, these are from a North Pole. We are given North, West, and so forth. So this is taken from the North Pole in this case. All right. So what I'm going to do is to present a North Pole in this case. All right. So let me just have it this way. All right. This is big enough. All right. So I'm going to have my North Pole. Remember having the east line and the west line together. Then we're gonna have this. All right. So let us just have it this way. I think we can understand much better if we've got this diagram presented like this. All right. So what we are given in this case, as we know, guys, this is our north and this is our south. We've got our east here and this is our west. All right. So presented from our cardinal points, we are given that the first is 40 Newton and it's north, meaning to say it's in the same north line. In the north line, that is where we have our 40 kilonewton, our 40 Newton in this case. All right, so we've got 40 Newton, which is directly in the north line. So there's nothing that you're going to do on this one. All right, then we've got 25 Newton to the west. So to the west, meaning we are taking this direct to the west line. We've got 25 Newton in this case. All right, so that's 25 Newton. Remembering that in between the north and the west, there is a 90-degree, also north and east. That's the 90 degrees south and east, and so forth. All right, so that is what we are given in this case. All right, so let's consider this one. We are given that we have got 35 Newton, which is east 30 degrees to the north. All right, so we are coming from the east, then 30 degrees going to the north. All right, so meaning to say we are moving from, so you state your movement is from east to north, like this one. This is our east, this is our north. So we are moving from east to north like this. This is the direction that we are taking. But in between this direction, we are having an angle of 30 degrees. So just approximating, because we know this is 90 degrees. So 30 degrees, just approximately, we shall have our 30 degrees somewhere here. All right, so this is 30 degrees somewhere here. All right, so I'm going to present my 30 degrees like this. All right, so let me put it this way. All right, so this is where we are approximating to have our 30 degrees from the east going to the north. This is the direction that we are taking in this case. All right, so this is the angle that we are going to have from the east going to the north, we have got an angle of 30 degrees. So this force we are given it as 35 Newton. So it's from the point going this direction. So that's where we have our 35 Newton in this case. All right. Then we move on to the other one. That's 30 kilonewton east, 65 degrees to the east. So this time we are moving from the east going to the south. That's east to the south. Okay, so that is the direction east to the south. So this is the direction that we are supposed to take. So in between this direction, we have got an angle of 60 degrees that we are going to consider from that direction. You're going to consider an angle of 60 degrees. All right, let me just approximate my 60 degrees somewhere here. All right, let me just put it this way. All right, so this is where we are going to have, remember, like I said, we are moving from the east going to the south. So this is what you're going to have from the east to the south. All right, so just somewhere here, somewhere here. All right, so I'm not worried about the angle much. I'm worried about approximating where our angle is going. So it's just an approximation. All right, so this is our approximation where we are going to have our 60 degrees. All right, from the east. So take note, this is taken from the east going to the south. So from the east going to the south, that is where we have our angle of 60 degrees in this case. All right, so this is what we are given, and our force at that moment is 30 kilonewton. So this force 30 Newton, so this force here is 30 Newton. All right, so this is how our diagram was going to be from the given forces that we have. From this information that we are given here, we are going to have our diagram in this way. So our question now is to calculate the sum of the vertical components. Take note, we are working with the vertical components in this case, and to state their direction. All right, so remembering that the vertical components are the one which carry sign. These are the ones which uses the sign of theta as long it is taken direct from the force that you are given. All right, so we are going to start 3.21. All right, so this is 3.21. So remember, I said vertical components, that's like this. That's a vertical component, this one. So according to this side, opposite this one, it's an opposite over hypotenuse, which is the ratio of sine theta. The ratio of sine theta, that's opposite over the hypotenuse in this case. So meaning to say we are going to consider the ratio of sine, or they are going to carry sine of theta, as long the angle is between the horizontal and the force that you are referring to. We take that angle as it is. That is how it is supposed to be. All right, and also taking note on your vertical components, as long it is above, it's a positive. As long it is down, it's a negative. All right, so let us combine everything. Let's start with 35. Back to E, this is a vertical component. It's on top, so it's going to be 35 sine 30 degrees. All right, so we are just combining everything. So our vertical components, we are going to have 35 sine 30 degrees. All right, so this is sine 30 degrees. Then we move on to this one. It's a straight vertical. It's in the north pole. So this one, you're going to just take it as it is a positive. So that's positive 40 in this case. So if you want to write the angle from the horizontal to this point, it's 90 degrees. So if you want to write the angle, it is going to be 40 sine 90 degrees in this case. All right, then 25 kilonewton is a horizontal. It's in the horizontal line, so this cannot be a vertical component. It's already a horizontal, but if you want to write it, it is going to be 25 the sine of 1/8, which is actually 0, so there's nothing that you're going to have from 25. All right, we move on to the 30 kilonewton. So 30 kilonewton is below the horizontal line. It's below this line. So if it is below, then it is going to carry a negative. So this is going to be negative 30. The sign of the angle in between from the horizontal, the positive horizontal side, this side, it is going to be the angle of 60 degrees. All right, so this is what you're going to have. So you combine everything from your calculator. This is going to give us something like 31,519 2, 3, 7, and so forth, which is to 3 decimal places. That is going to be 31,519 Newton. So take note the units that we have. It's in Newton in this case. So a vertical component, as we can see, being a positive means it's going up, which is to the north. Being a negative is going down, which means it's a south. So here we obtained our vertical component being a positive. So meaning to say we are going up, which is a north. So our direction in this case is going to be to the north. All right. So that is what we had in this case. The other part of our question 3.22 was to calculate the sum of the horizontal components now and state their direction. All right. So what are we going to have for the horizontal components? So the horizontal components, these are the one which uses the cosine of theta. So we are going to consider this time the cosine of theta as our horizontal components. All right, so let's see what we are going to have. All right, so this is 3.22. All right, so in 3.22, we are going to have our horizontal components. All right, like I say, they use the cosine of theta, vertical components, the sine of theta. All right, so let us check the first one. 35 kilonewton presented to the horizontal, that will be 35 cos 30. All right, so we're going to have this as 35 cosine of 30. So that's 35 cos 30 degrees. Okay, the other thing that you're supposed to consider for the horizontal, we are talking about to the right, that is a positive, to the left, that is a negative. All right, so that's how you consider horizontal components. To the right, from the origin to the right is a positive, from the origin to the left, it's a negative. So this is to the right from where these forces meet, it's to the right. So that's why I present it as a positive. And again, if you check 40 kilonewton, it's a straight vertical component. This one can never be horizontal. So just leave it like that. Then we've got 25. 25, it's a horizontal line. Like I said, it's going on this side, which is on the negative side. So this is going to be minus 25, which is a straight horizontal component that we have. So this is just going to be negative 25. So if you want to use cos whatever, then you're going to use cos 30, cos 180. But this is just directing negative 25. All right, then we move on to another part. So like I said, if you want, you can write cos 180 to represent the angle. Then we have got this part of 30. So 30 is the horizontal. If we take it to the horizontal side, it's going to be on this side, on the positive. So this will be positive 30 cos 60 degrees. So we are going to have cos positive 30 in this case, cos the angle of 60 degrees. All right. So this is what you're going to have, or the information that is important that is going to give us the horizontal components in this case. All right, so this is going to give us something like 20,31089, something like that, which is to 3 decimal places, that will be 20,3118 is going to change 0 into 1. That is Newton. So you saw the units that we are applying, or the units that we are using here, it's Newton in this case. And also horizontal component, if it is to the right, as we know, this is east and this is west. So if it's a positive, it's east, and negative, it's a west. So this one is a positive value, meaning to say we are going to the east. So this is to the east. All right. So that is what is important on your simplification. The direction has to be presented. Then now they're giving us on 3.23 to find the magnitude of the resultant force, the magnitude of the resultant force. All right. So what you do is that you work with the components that you calculated on this part. This is no longer about the original diagram. You go back on this on these values that we calculated now. We have our horizontal component here. So I'm just gonna have it aside here. This is 3.23. All right. So we need the sum that is of everything, the resultant in this case. So what you do is that you consider your vertical component and your horizontal component. Our vertical component is going to the north. Our horizontal component is going to the east. All right. So meaning to say, this is what you're going to have. All right. So on our final diagram, we are going to have it somewhere like this. All right. So we are saying that in this case, let us consider our horizontal component. This is our horizontal component, vertical component. So our horizontal component here, which is the one that you're given, is going to the east. It's a positive. So meaning to say we are going to have our horizontal component going to the east to the positive like this. All right. Then our vertical component is going to the north. So our vertical component, we just join from the end point, you join it. It's going to the north, meaning to say it's going up, not down, but it's going up. So this is going up straight. So we are going to have this one going up straight as a vertical line. All right. Then what do? You join from the origin to this point. You are going to join like this. All right. So this is our resultant that we are supposed to calculate. All right, so like I said, this is our vertical component from what we saw. I mean, this is our horizontal component to the east, which is 20, 311, and our vertical component, this is our vertical component, which is 31, 519. All right, so this is the diagram that we are going to consider to calculate the resultant. And on our resultant, we can see that it goes together with this angle now as the direction for the resultant. So this will be our theta, which is our direction. All right. So from our Pythagoras theorem, we can calculate the resultant. Since we are given two sides, it's a right angle triangle. So we know that from our Pythagoras theorem, our resultant is going to be the square root of the side, the horizontal component squared plus the vertical component squared. So that means our resultant is going to be the square root of horizontal component 20, 311 squared plus the vertical component squared, which is 31, 519 squared. All right, so this is what you're going to have. So meaning to say our resultant is going to be something like 37, 496, 45, and so on and so on. So if you round off to 3 decimal places as for instruction of our question paper, this is going to be 496 Newton in this case, as we saw that the other part that we had, this was in Newton and this was in Newton. So meaning to say our resultant is going to be also in Newtons. All right. Then we also have to calculate its direction. So according to our diagram, if we check our direction theta, we have got, according to theta, this side is our opposite. So we have got this side here as our opposite and this as our adjacent. So which ratio can we consider which has got the opposite and the adjacent from our soccer tower? So remember, from our soccer tower, in this case, we need the ratio that he has got the opposite and the adjacent at the same time, which is ratio of tan. So that means the tan of theta is going to give us the opposite over the adjacent, which we are considering in this case our opposite as the vertical component. This is our vertical component. So it's the vertical component over the horizontal component. That means the tan of theta is equal to 31, 519 everything over 20, 311 like this. All right. So this is what you're going to have. So in order for us to determine theta, our theta is going to be arctan. So this is arctan of this part that you have as it is 31, 519 over 20, 311. What do I mean when I'm saying arctan? Arctan is simply shift tan from your calculator. All right, so this is what we are going to have from our calculator. Let me show the screen. All right, so this is going to be shift tan like this. Make sure that your calculator also here is in degree mode. All right, so shift tan 31, 519 everything over 20, 3. So this is 20, 311 like this. All right, so this is arctan or shift tan like this, which is going to give us 57, 202 and so on, which is to 3 decimal place. That will be 202. All right, so we are going to obtain our theta as 57, 202 degrees. All right, so this is what we are going to have as our theta. So meaning to say our resultant as at the end, our R, which is representing our resultant, can be given as the resultant that we got R here, which is 37,496 Newton. Then the angle that we have, if we check properly from our diagram here, this angle is between, this is our east line, this is our north. So this angle is taken from the east, we are going to the north. From east, we are going the north direction. So meaning to say we are going to have east, all right, we are going to have our angle here from the east going to the north. But what is the angle that we are going to have in between? That is our angle theta. So we are going to have east 57,202 degrees to the north. All right, so this is how you have your resultants. This is how you calculate the resultant force from. So like I said, it's from the vertical and horizontal components that you calculated before. You use these, but take note, how are you going to present it on your diagram? Sometimes you might find your triangle on this side, maybe you're finding your triangle on this side, or you're finding your triangle on this side, or it can be on this side like this. It depends with what you are given. The information that you're given is the one that helps you to draw the triangle. But never are you going to find a condition like this where your triangle is going to be drawn like this. There is never a condition like that. Your triangle is always like this. All right, so please take note on how you are going to present your final answers. All right, so that is what we had on this question, the first part of the given forces that we had. Then we move on to question 3.3, which is again on forces, but what exactly are we given? We are given on question 3.3 that the direction of the force, so take note about your information, the direction of the resultant force of a system of forces acting on a point is west 42,7 degrees to the south. Okay, so take note, we are given the resultant. While the sum of the vertical components, all right, so we are given the vertical components, which is 300 Newton. All right, calculate the magnitude of the resultant force. Take note, guys, this type of a question. They are giving us the part. Remember the diagram that I drew before, the one that I used to calculate the resultant force. Remember what we used? We used the horizontal and the vertical components in order for us to draw that diagram. Now they are giving us the resultant force with the direction from west to south. So this is going to help us to present our diagram, to say our resultant was going to be presented this way. If we note this one, we were going to have our resultant like this. All right, this is our east, all right, our west this side, our north, and our south. So our resultant was supposed to be taken west to the south. We are moving from the west going to the south like this, from the west to the south, meaning to say this is where our resultant is, somewhere here. This is where our resultant was with. But the angle that we are given is important. It's between west and south, between west going to the south, which means we're talking about this angle in between here. That's where our angle is 42,7 degrees. So now at this point, we are given, remember our triangle, I said our triangles, they are going to be taken from this like this, our triangle like this, our triangle like this, our triangle like this, our triangle like this. So meaning to say in this quadrant, we are going to expect our triangle of this nature. This is the one. So we are going to join from this point. This is how our triangle was going to be. So on your triangle, this is the horizontal component. This is the vertical component. So what are we given here? We are given the vertical component. This part is the one that we are given as 300 Newton. So we are given this one as 300 Newton. We are given the vertical component. This is one that you're given. We are not having the horizontal component. So our question is, calculate now from this diagram that we see, calculate the magnitude of the resultant force, which is our R in this case, this one. How can we, so you see, guys, they are playing around with us. If you understand how this diagram works, then once you are having this, you are now left with a normal right angle triangle. This is no longer about forces, guys. This is now into mathematics. You're now into mathematics now, to say, according to my diagram that I'm having, according to this theta, the angle that I'm having, this side here is the opposite. The resultant that we want to calculate in this case is our hypotenuse, the one that is that faces the 90 degrees. This is our hypotenuse. So there is only one ratio which uses the opposite and the hypotenuse at the same time from our SOHCAHTOA concept. Remember, from our SOHCAHTOA, which ratio has got opposite and hypotenuse? That is opposite hypotenuse on the sine. So meaning to say the sine of theta is equal to the opposite over the hypotenuse in this case. Meaning to say the sine of angle theta, which is 42,7 degrees, is equal to the opposite. Our opposite is the one that you are given, which is the vertical component. So you're given the vertical component of 300 over the hypotenuse, which is the resultant that we want to calculate, which is R. So in this case, we can calculate our R, which is the resultant. So we can play around our values, remembering that this is same as over 1 as a fraction. So we can cross multiply. That is R times sine is going to be R sine 42,7 degrees, which is equal to 1 times 300. That will be 300. So to find R in this case, we can divide by the sine of 42,7 degrees both sides by the sine of 42,7 degrees both sides. So this is going to give us the resultant, which is R. All right. So if we divide direct, so this one just divide direct from your calculator, we are going to obtain 442,374 Newton in this case. So taking note of the units that you are given before, we were given a vertical component as 300 Newton. So meaning to say our resultant is going to be also 3 in Newton. All right. So maybe you understand this formula of using the horizontal component and the vertical. You wanted to use that part. Yes, it's fine. You can use that part, but you are going to calculate the horizontal component. So this, you could have calculated the horizontal component because we know that the tan of theta is a vertical component over the horizontal component. So meaning to say, I can calculate the horizontal component from this because I can simply substitute the tan of theta being equal to 42,7 degrees is equal to the vertical component of 300 over the horizontal component, which is I do not have the horizontal component. So what I'm going to do, I'm going to calculate the horizontal component. After calculating the horizontal component, I can calculate the resultant because we know that the resultant, like we saw from the previous part that we calculated, the resultant is equal to the square root of the horizontal component squared plus the vertical component squared. So meaning to say, we can also calculate the value of R through this way by first calculating the horizontal component. So you just make horizontal component the subject, that will be HC. You calculate it, then you can use this formula. Since you now have horizontal component and vertical component, you can calculate the resultant. All right, so there are actually so many ways that we can apply as long we are following the exact concept of a right angle triangle. We are working with a right angle triangle, so we have to apply all we know about a right angle triangle. That is the major important part. All right, so that was our question on the calculation of the resultant force when you are given one of the components. So sometimes you might be given the horizontal component. You work with the information that you are given. But what is important is the direction. The direction gives us the exact quadrant where we are going to have our triangle. Are we going to have it in the first quadrant, in the second quadrant, in the third quadrant, or in the fourth quadrant? All right, so that's it, guys, from Maison African Motives. Till we meet again.